So we'll talk about exponential regression. This is used to model situations in which growth begins slowly, then accelerates rapidly without bound, or where decay begins rapidly and slows down to get closer and closer to zero. You use the command, if you're using a calculator, expreg on a graphing utility to fit an exponential function to a set of data points. This returns an equation in the form y equals a times b to the x. So b is not negative, b is greater than 1. If it's growth, it's between 0 and 1 if we have a decay. And in using Desmos, I use y1 tilde a b x1. So in 2007, a university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,871 crashes were used to measure the association of a person's blood alcohol level and the risk of being in an accident. Table below shows the results of the study. Relative risk is a measure of how many times more likely a person is to crash. So, for example, a person with blood alcohol content of 0.09 is 3.54 times as likely to crash as a person who has not been drinking at all. So you look at the data here. It's in this table. Pretty interesting. So if your blood alcohol level is 0.21, first of all, you're getting close to alcohol poisoning, and you're almost 100 times more likely to get in an accident than if you had not been drinking at all. So let X represent the blood alcohol level, let Y represent the corresponding relative risk. Use exponential regression to fit the model to these data. So I didn't want to waste your time with, there we go, with inputting the data. So I put all the data points in. And you can see them here. I changed my window to go from negative 0.05 up to 3.5, which you see all the data points, and from like negative 10 to 100. So you see that scaling there, the vertical scaling, just so you see the relative data and what is meaningful. So I got a window that's workable. And then I took and I said y1 tilde a b to the power x sub 1. So those subscripts, those reference the x1 in this column and the y1 in this column. I'll turn this on. Boom, there's our curve. It looks pretty good. Our r value, r squared, is 0.994. So that's a really strong connection there. And so we have our a is 0.398595, and our b is 28485 times 10 to the 11th. Well, that's a big number. Okay, so let's go ahead and put this down. And what we're after is we're going to come up with a formula as we have, and then we're going to see after 6 drinks, a person weighing 160 pounds will have a blood alcohol content of 0.16. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? And then we can round to the nearest hundredth. So let me get this formula down here. And I guess we'll do it this way. A of t, I don't know why it went blue back to black, but that's strange, equals 0.398595 times 2.8485. Oh, this is what happens when I'm watching my other screen than the one I'm writing on. 2.8485 times 10 to the 11th. That's crazy. All to the x, or to the, I guess, t power, because I put t there. And so we're looking at 0.16 is what we're after. So the amount, let me scroll up a little more, for 0.16 is going to be 0.398595 times 2.8485 times 10 to the 11th. to the power of 0.16. And let's see what we come up with. As I run that through my TI calculator, I get 27.1188. Time is more likely to get in an accident. Now, by the way, I'm comparing my answer to the one in the book, so I want to say that an answer is a little bit off, and this could be a case when you're working these out. And I would believe that the way the homework assessments or homework assignments are going to go, that they're going to be based off of Desmos, since that tool is related to this, and they may be probably using the TI-84, and that's what I found. There can be some slight calculation differences. So they came out with 26.35, and I came up with 27.1188. But unless I had entered the data set incorrectly, but I think that's pretty spot on. I mean, they're still pretty close. So we'll go with that, and that is our exponential regression. Really not a bad process, and I have went too far. I have in the past done this also with other programs. I think I've done it with Excel as well, but even in math specialty programs, done this with. Okay, see you in the next video.